And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, and today we're looking at making an HF antenna that we're going to sort of string like that on the house from this point here on the eaves down to right on the corner of what is the end of sort of the kitchen extension over there. And the idea is to put a doublet up, but it's going to be a slightly experimental antenna, because I've seen this done a few times where people have linear loaded dipoles. Well, can we linear load a doublet? Only one way to find out, really, and that's let's build one. So here is my house. You can tell because I've had a new roof and next door hasn't. So the idea is, this is where I was stood a minute ago, and the idea is we want to string an antenna from this corner here over to here, and also the opposing element down this side. Yeah, you know, it should be in a straight line maybe, but we can't do that. So yeah. So if I click on the measurement button here, we can sort of see what measurements we're playing with. So we've got about 10 meters there. And okay. And I need to see how many we've got the other side. So do that again. And I've got about 9 meters that side. So what I'm actually going to do is, for the first time ever, we're going to cut the aerial slightly short, because I want a bit of something to sort of tie onto the end of the element. But of course this section is actually elevated above this flat roof here by sort of 2.5 meters. So it will be a little bit longer. Now, I don't have a tape measure that'll measure 10 meters. Mine only goes up to 8. So what I'm probably going to do is measure that with a bit of string and yeah, go from there. The other thing I need to tell you about linear loading, really. So yeah, let's draw a little diagram and do that. Right, bit of a drawing. So this is the plan. So we're going to have a doublet. And it's going to go up to the corner of the house. I'm not going to draw the house in because it's just going to overcomplicate matters somewhat. So a doublet is a sort of non-resonant antenna, shaped a bit like that. And because it's non-resonant, we're going to need to tune it. So what I'm going to do is I'm going to bring this down with a bit of ladder line to a tuner. Now, the linear loading bit. So if people make a linear loaded dipole, if you follow Callum's DX Commander Blokes channel, you'll have seen this. You can double the sort of element over a bit, like that. Same at the other end. Let's keep it sort of balanced. And you can make it look electrically longer than it actually is. So that's going to be handy. Now, by the look of those dimensions, what did we have? We had about sort of 9 meters. We're going to get away with maybe 10. So, well, we're going to be somewhere near a 20 meter half-wave dipole. That'd be really nice. I'd really like 20 meters. I wouldn't mind 40 meters, and anything else is just a bonus. The higher bands, we should be all right. Now, I've also seen this idea mooted, which I'm going to try. So instead of just loading it once, we're going to do this. We're going to load it effectively 3 times, like that. And then we're going to have a bit of line there just to anchor it to the corner of those flat roofs at the other end. Now, I don't know where it's going to work on a doublet. It works on a dipole allegedly, but Who knows about a doublet? Now at this end we are going to need, so obviously our radio here, there we go, radio, coily lead, microphone, oh great. This output here is going to be 50 ohms. This here is going to look nothing like 50 ohms. It might do if we're lucky, but no. So the way to feed a doublet properly, rather than, you know, if it's a resonant dipole, you can get away with a bit of coax, even though you shouldn't, because effectively a dipole is a balanced antenna, and you're feeding it with an unbalanced 50 ohm from the radio. There's a lot of getting away with that, and that's fine. So what we're going to need here is a balun, which is a transformer, and we're going to use a 4-to-1 balun. So this side's our balanced side, and this side is going to look more like 50 ohms. It's not going to be like, so 4-to-1 balun. If we put 50 ohms in this side, we're going to end up with 200 ohms at this side, and we might be somewhere near at that. But then what we're going to do is this is then going to be a piece of coax, there we go, and that is going to then feed an ATU that's not tuning our antenna, it's tuning our match, and then the 50 ohm coax into the radio. The reason I can do this, I mean, we could put the ATU right up here, or the balun right up there, and then run coax down, you think. But again, chances of this looking like 50 ohm, minimal. And if we run a mismatch on a 50 ohm bit of cable, we get buckets of loss. So ladder line, I'm not going to buy it, we're going to make it. We're literally going to make the dipole, make this piece of wire one, and then make 3D print some little spacers here. And in fact, some sort of, let's draw that in a different colour. Where's me green? I like the green one. There's me green. These things are going to be sort of 3D printed spacers to hold the line, make it look something like. We're going to 3D print some little spacers to hold these elements about right, like that. I shall share the link to Tinkercad for those if you want to have a pop at making one of these. It might be a disaster, you might be wasting your time. Wait till the end of the video when we see if the damn thing actually works. In fact, it's not going to be this video, it's going to be next week. So there we go. We're going to need a 4-to-1 balun, of which I bought some baluns recently because they were cheap on AliExpress. These Chinese type baluns. There's a 1-to-1 here for going between unbalanced and a balanced output, and a 4-to-1. But I'm thinking we might make our own. Yeah, these are nicely made though. Bit of pipe look, all sealed up, very lovely. It's got a SO239 on the end. But I'm thinking we'll probably end up making our own. So we need a 4-to-1 balun, which we're going to have to make. We're going to have to make all this. Then we can have a short piece of coax, if at all. Now, in years gone by, and I'll insert a picture here, if I can find it, I used to have a doublet on the top of my old house, whereby I had a box right at the feed point, and that just had an ATU and one of those automatic ATUs on it. So that was fed back to the radio down in the shack, and then that just fed out to the doublet. And that was quite short. It used to really work well on 24 megahertz. We used to get over to the States quite a lot with that. So that's the sort of idea. So what I might do this time is put our 4-to-1 balun in here. That sort of 4-to-1. And then mount that outside the window. So we've actually got something that looks a bit like 50 ohms coming into the shack or the back of the workshop. So there it is. There's the plan. It might be stupid. I don't know. Let's go and make it and find out, shall we? Right, well, I'm stood on the sort of flat roof section, and just up there, we swing the camera around. That is where I'm sort of planning to mount the feed point to the antenna. So we're going to have a dipole centre in there and a piece of ladder line running down here to a 4-to-1 balun into an ATU by a short piece of coax, maybe even build that into the same box, and then down into the workshop where we've got the radio. The other end of the dipole is going to swing down over to that, which is the corner of my garage, and I should say doublet, and also that corner over there, which is the corner of the kitchen. Now the beauty of this is it needs to meet the two criteria for antennas, i.e. it's got to be happy with the wife and it's not got to upset the neighbours. Therefore, just like the VHF antenna, which is just behind me here in the sort of low position, see that bit there? Are we in shot? Oh yeah, we are. So the idea is that I should put it on a pulley with a piece of rope, so when it's not in use I can lower it and it'll just fall onto the flat roof and be invisible, except for maybe the rope, but it's only a bit of rope and a pulley. Right, the next problem I've got is that as we saw on Google Earth, the distances are maybe a little bit larger than 8 meters, and that gives me a problem with measurement because my tape measure only goes to 8 meters. So to get around this problem, I only want a relative measurement. I don't want to know the exact length because a doublet isn't resonant. So I'm going to use a bit of string. I'm going to put the piece of string over in the corner, measure the distance, mark it on the string, mark it down to that corner, and whichever distance is shorter, because I want the antenna to be the same length on both legs, that's the dimension we're going to go with. Right, let's make that happen. Got a few bits and pieces up here with me. I've got a piece of string, I've got a Sharpie, I've got some sort of sticky tape. I haven't got the Sharpie, I've left it down the bottom. Oh no, but it'll be all right. We'll do without it. And I've got a brick. The brick's just going to stand on the edge of the string. I shall make my length, turn it round, go the other way. I suspect the garage leg is going to be slightly longer than the sort of leg that goes over to the kitchen. So yeah, let's get on with that. Right. There's our sort of feed point area. So I need this to be quite tight up to there, and it is about that long there. So I'm going to attempt to tie a knot in that bit, just as a marker, because I've forgotten my Sharpie. Let's just check that again. Oh, I'm a bit short now. But I tell you what, if I go from the end of the string and not where the knot is, it's going to be about right. I wanted it a little bit shorter anyway, this, because I've got to allow for some a line at that end, which is going to be insulated, so it won't be made out of the wire, and it's the wire length I'm interested in at the moment. Right, let's repeat the process. So I suspect this is going to be the longer leg. Oh, it is a lot longer. Okay, so that is where my measurement ends. That is the shorter leg. I want them the same, so that is our measurement complete. Right, let's get back to the safety of terra firma and see if we can find some wire to make this thing. Right, so this is the stuff I've got to build my antenna with. We've got electric screwdriver, electric drill. This is the wire I'm going to be using. This is so-called lightweight antenna wire, and it is lightweight. We've not really got much in the way of a conductor in there, but it is quite strong. I've used it great success before. I think it's sold, I can't remember, SOTA Labs, the SOTA, Summits on the Air people. I think they do it. I've had lengths of this up for years before, and it's been very good. And you know, I'm not running kilowatts. Maximum sort of I ever use really is about 30 watts on HF, so it's not going to be much of a problem. Right, that's that. And not only that, but this stuff is, by the way, dirt cheap. 100-metre roll, about 14 quid, I think. Although I haven't bought any for a while, so don't hold me to that. We've got some 3D printed parts. Me and the 3D printer got busy. I printed a couple of dog bone insulators. They're PETG, and unfortunately they've come out a bit hairy, but they'll work fine. That's for at the ends of the antenna, so we've got 2 of those. I've got 4 of these, which are discs with 3 holes in. I'll show you what they're for later, but they go at the end, each end of each leg. We've then got some of these little diamond-shaped pieces. They are going to keep the conductors, each conductor on the antenna, out the way of the next one. And then there's these little slotted, again, look a bit like a dog bone shaped piece, and they're going to form our ladder line. I'm going to attempt to make it in one whole piece. What else we got? We've got this cheerful looking chap. He's our dipole centre, so the idea is single wire comes in, loops around these holes, and then loops down these holes and forms our ladder line going back down to the tuner. Right. That's all the 3D printed bits. I've got a pulley for the top and a hook. I've got 2 sets of those because I'll show you why later, but I need to make sure the rope sort of goes down by the side of the house. When I pull it up, it all comes up straight. That's the idea. I've got this. Now, if you've ever seen one of these in one of those bit sets and not known what on earth it's for putting these in. It goes together like that in the end of your electric screwdriver and drives the hook in. Not the most stable thing in the world, but we might need that, so that's there. Now, when I said this antenna was stealthy, I don't know what possessed me, but I've bought some bright orange paracord for the rope. So there we are. Wire cutters, electric drill with a tiny bit in it just to enlarge some of these holes because I printed them too small on purpose. Right, yeah. Oh, some liquid electrical tape because these are likely to move around a bit. Just a dab of that on there will keep the spreaders in place. I'm also going to need some zip ties because this dog bone thing, the idea is with a ladder line, because I'm going to make 2 parts separately, it'll come in and then I'll put a zip tie around it and just make up the ladder line. Right, I think that's it. These 3D printed parts, by the way, I will share in the description down below. Now we've got the tedious part of measuring out the wire and getting it all to happen. Push fast forward. That one first. So that's how this piece operates. This is the ladder line, 1/2 bit going down to the ballon and tuner, and this will be the first part of our radiating element. So you can just see it's sort of woven through there. Same the other side. Right, I'm just going to put this tiny smear of black liquid tape on there just to stop it moving. And now I'm going to put the kettle on because this is going to be a really long, tangly and tedious job. So the next job is to fit one of those round pieces by the dipole centre, followed by, I reckon, 6 of the sort of diamond shaped pieces, another round one at the other end. Right, and that's got to be all threaded through. Wish me luck. So I needed to add another diamond piece in there. Not a great loss at the minute, so that's 7 for my particular length. Now we come to the other end of the round one. We want to go the first time. You just go into one hole and then round and back out again so we can head up again. This job gets easier as it goes on. There's less to tangle up. It's very important to solve those tangles as you go, because once you've got one in the middle, you've had it. We're doing great. So I'm just up at that end. I'm just going to put a blob of tape, electrical tape, the liquid tape, on that disc, that end, because there's a gap between the dipole centre and that disc with one strand in. So ideally I just want to stop that from moving, so I'm just going to put a dab of that on one, wait till it dries, go and have another cup of tea, come back and then make the last piece. It's going quite well. I'm on the home straight. I think that's the first section made. I'll just take you over there and talk you through it a bit. So yeah, that didn't take really as long as I thought once you get going. So yeah, just flip the camera. So that end of the wire there attaches to the dog bone, goes to our first sort of three-way splitter thing, and we've got parallel wires running around which forms our linear loading. We've got our second three-way disc just mounted to the back of that vice there, look, and then there's the dipole centre, and then that goes off rope there. This is this connector, my little fingers here, this lead here going past my foot, that forms the ladder line. So oh yeah, there it is. Hell of a job, beautiful day for it though. Now I've just got to make the same again for the other leg. Right, you don't want to see it twice, do you? Didn't think so. I shall be back in another hour and a half. Right, well, quite a few hours later, this is what we've got. So there's the dipole centre up there, and here are two sort of triple folded elements. I don't think you can see that on the camera, you can sort of see it up this end quite well. And yeah, the two lengths are pretty similar, so I'm quite happy with that. Right, I suppose the next bit is just to fix all the spreaders in the right sort of place. Blob of hot melt maybe, or even better might be just a bit of that tape in a jar thing. Yeah, let's do that. Right, so I just got the dipole centre hooked on the fence. And I've just put the spacers in. I've used the diamond ones again actually because I'm quite pleased with those, at least for this section. I haven't got as many as I wanted, but I think the ladder line section isn't going to be as long as I need to be. I mean, it's a good 4 metres long, I should think, but we'll see how long it needs to be, and if needed I can add a bit more on. I've got plenty of wire. What I haven't got is more diamond shaped spacers, but we'll see how we get on. Right, next job is to fit the pulleys that's going to hoist the antenna up when it's not in stealth mode. For that I've got to get a pulley up there, up around here somewhere, and also one lower down, sort of on here somehow. I know this board's horribly rotten, but I know there's stuff behind there, it's okay. So the rope can come down and then off without getting tangled up. That's the plan anyway. So first things first, I need to sort of work out where the pulley wants to be. It wants to be there really, doesn't it? So I can go into the end of that, or even into the end of that, might be better. Brilliant, okay. What I'm going to do is I'm going to drill a pilot hole in there and hopefully hit something solid. Not sure whether that felt solid or not. Let's just try spinning a hook in there and see how hard it sort of goes in. Where's my pilot hole? There. Okay. Ooh. Let's try the magic hook attaching thing. Well, you can see what I'm doing actually. Let's go up a bit. There we go. Right. So we just get that started. Oh, the sun's right in my eyes. Oh yeah, that seems to be quite good. entirely convinced that's the firmest fix in the world. It hasn't got to hold much weight. I think that's going to be fine. So there's pulley number 1 installed. So go with pulley number 2. I want to sort of come down here really. Pulley number 2, so the rope's going to come down like that and off over the rope. Over the roof. Talking of rope, I've got my stealth coloured paracord here. So start threading that through, I guess. So my dipole centre is going to be on that pulley there. Zoom in so you can see. So when I pull it, that will elevate it into the operating position. So I wonder if I can actually haul it up onto the roof like that. Might be a good idea. I'm going to get all this paracord untangled now and move back down onto the ground. Right, I've attached the dipole centre onto the cord. It goes all the way up to that top pulley. The knot I've chosen is the double granny with zip tie. A Boy Scout I am not. Right, let's gently hoist the thing in the air and see if we can see if we've made any huge errors. I've got a feeling it might be too long, but hey, I can always shorten it. Slightly snagged up on that stand. There we go. Oh, slightly snagged up on the VHF mast. There we go. Well, I appear to have more than enough ladder line, and I'm at the top, so that's good. I need somebody to tie this off now. I'll tie it around there. Okay. And now I better carry on up with the elements and everything else. We'll see how, if it's too long. Actually, I only want the elements, don't I? I don't want the ladder line. So those are those two. Yeah, I'm going to cart this up and then get organised up there. Right, I shall see you in a moment. Right, so let's come up with a system for mounting the dog bones on the corners. This is at the kitchen end of the life. You see that bit of paracord? That's connected to the dog bone that's on the roof. I've performed a similar operation on the front. So yeah, let's go and connect that up to get the thing to be taut when it's in the upright position. So yeah, with that in mind, just I raise it up again. So you see it there? Yeah. Okay. Let's get up there and sort of tension the dipole elements, or each active element, shall we say. Okay, so end of dipole dog bone. Let's see where we need to stretch it out to. Doubling back on there, so that wants to come to about there it is. Right, double granny again. What Scout's done me proud. So, those in through the insulator. Tensions that up a bit more. There we go. And just zip tie that into place. That's one. Let's go and do the other. There's the other shot. Look, that's where it's all ending up to. Looks quite good, really, I think. So behind the rope. Blustery up here again. Oof. And at that point, of course, the memory card got full. You get the idea, though. So, yeah, there it is. The sun's at a bit of a suboptimal angle, to be honest. Let me just turn around here. And you can just see the ladder line coming down there. And then one element goes across there, and the other element down the side of the garage, which we can't really see. But there we go. So, the next thing we need to do is build the matching section and decide what we're going to do for an ATU. But that's a job for another day. So come back next week here on Doz's Television Workshop, where we'll investigate that further. Cheers now. Bye.